Hello, good morning, everyone. Thank you for being here today. Before we begin, let me introduce myself. My name is Nila Kaputriani, and today I would like to present our topics about limits. In this presentation, I will explain the basic concept of limits, discuss several examples, and show how to solve limit problems. I hope you enjoy the presentation and find it usable. Okay, let's begin. Okay. Now, a limit describes the value that a function approaches as the input variable approaches a certain number. Now, in mathematics, limits are fundamental because they form the basic of calculus, including derivative and integral. Now, the mathematical notation for limit is the limit of fx as x approaches c equals L. Now, sorry. Okay, next. Now, consider the function f(x) is equal to 2x plus 1. Okay, suppose we want to find the limit of 2x plus 1 as x approaches 2. Now, let's examine values of x close to 2. Okay, for x is equal to 1.9, and we get the fx is equal to 4.8. And for x is equal to 2.1, and we get the fx is equal to 5.2, and so on. Okay, now we can conclude now, as x gets closer to 2, the value of fx gets closer to 5. Okay, therefore, the limit of 2x plus 1 as x approaches 2 is equal to 5. Next, okay. To understand a limit completely, we have to look at it from two directions. The left side, values smaller than c, and the right side, values larger than c. Okay, we have left hand limit and right hand limit. Now, the value of x approaches as x gets closer to c from numbers smaller than c from the left. Okay, the limit of fx, the left hand limit of fx as x approaches c. Okay, next, the right hand limits. Okay, the value fx approaches as x gets closer to c from numbers larger than c from the right. Okay, we have the right hand limit of fx as x approaches c. Okay, then a two-sides limit only exists if the left-hand limit equals the right-hand limits. So the limit of fx as x approaches c is equal to L if and only if the left-hand limit of fx as x approaches to c is equal to the right-hand limit of fx as x approaches c is equal to L. And next, let's move on to the properties of limits. Let the limit of fx as x approaches to c is L, and the limit of gx as x approaches c is M. Then we have the constant formula, that is the limit of k as x approaches c is equal to k. Then we also have identity formula, the limit of x as x approaches to c is equal to c, and so on. You can read this until we have the root formula, that is the limit, and we have the limit of the n roots of fx as x approaches c is equal to the n roots of L. Okay, you can read this. Okay. Now let's move on to the method of evaluating limits. The first method is direct substitution. Okay, this method substitute x is equal to c directly into fx. Now, this method works when the function is continuous as x is equal to c. For example, evaluate the limit of 2x squared minus 4x plus 5 as x approaches 3. Okay, the solution from this problem, okay, simply plug in x is equal to 3 into the function. So we get 2 times 3 squared minus 4 times 3 plus 5, and we get 11. So the limit of 2 times x squared minus 4x plus 5 as x approaches 3 is equal to 11. Okay, next, the second method is factoring. Now, sometimes direct substitution gives you 0 over 0. Now, this means there is a hole in the graph. So, and we need to simplify the expression by factoring. For example, now evaluate the limit of x squared minus 4 over x minus 2 as x approaches 2. Okay, now if we plug in x minus 2, we get 0 over 0. Okay, so this is in the indeterminate form. And so we must factor the numerator. And we get x squared minus 4 over x minus 2 is equal to x minus 2 times x plus 2 over x minus 2. And then we can cancel out the common term x minus 2. Now apply the limit via direct substitution. So we get the limit of x plus 2 as x approaches 2 is equal to 2 plus 2, and we get 4. Okay, so the limit of x squared minus 4 over x minus 2 as x approaches 2 is equal to 4. Okay. So then the last method is rationalization. Okay, if the limit results in 0 over 0 and contains a square root, multiply the numerator and the denominator by the conjugate. For example, evaluate the limit of the square root of x plus 1 minus 1 over x as x approaches 0. Okay. The solution, direct substitution gives us 0 by 0. Sorry, 0 over 0. Okay, let's multiply by the conjugate of the numerator, which is the square root of x plus 1 plus 1. So, okay, we can write the limit of the square root of x plus 1 minus 1 over x times the square root of x plus 1 over the square root of x plus 1 as x approaches x approaches 0. So using the difference of squares, a minus b times a plus b, and this is equal to a square minus b squared. So we get the limit of, and we get the limit of 1 over the square root of x plus 1 as x approaches 0. Okay, now plug in x equal to 0, and we get the limit of 1 over the square root of x plus 1 as x approaches 0 is equal to 1 over 1 plus 1, and we have 1 over 2. Okay, that's about 3 methods in evaluate the limit. The next topic is limit at infinity, x approaches infinity for rational function. Okay, for the limit of px over qx as x approaches infinity, where px and qx are polynomials, we have 3 conditions. The first condition is if n is less than m, numerator degree is less than denominator degree, and we have the limit is 0. For example, the limit of 3x over x squared plus 1 as x approaches infinity is equal to 0. Okay, the second condition is if n is equal to m, equal degrees. So the limit is a over b, ratio of leading coefficient. For example, the limit of 4x squared over 2 times x squared plus 5 as x approaches infinity is equal to 4 over 2, and then we get 2. Okay, the last condition is if n is more than m, numerator degree is more than denominator degree. So the limit is plus minus infinity, depends on sign. So for example, if the limit of x to the power of 3 over x squared plus 1 as x approaches infinity is equal to infinity. Okay, then I have some practice problem for you, so I hope you can try to solve these problems about the concept of limit. Okay, you can try. Okay, that's all of my presentation about the limit. If you have any question for me, you can comment in this video. So I hope this video has helped you understand the basic concept, properties, and method of evaluating limits. Thank you very much for your attention. Have a great day and see you in the next presentation. Bye-bye.